without further ado, hi everybody. Thanks for joining the session. I'm Shubhi Panicker. I, was a Blink and Platform API engineer, so know a lot of folks in this room. I've shifted focus from APIs to the developer ecosystem over the last year and a half. And so this talk covers at a high level the set of loading challenges that we've encountered while working on my project that is called the Web SDK internally at Chrome. And it's an ecosystem initiative that's currently focused on performance of framework-based apps. I also have a talk tomorrow at 10:35 PST. That's about kind of the larger project, what it is, what we learned in the last year, including non-technical aspects. So all that is out of scope for today. Today's talk is about problems, both technical and ecosystem challenges with loading. And by loading, I kind of mean from the perspective of a developer. So that includes everything from bundling to serving. All right. So just to get started, so as I said, in the last year and a half, we spent a lot of time into digging into what these problems are. And it's just sort of, keep finding layers and layers of problems. And the main tool I would say we have predominantly used is deep tracing with Chrome tracing, and often using web page test and Chrome dev tools to capture and examine traces and analyze websites. And this is kind of a popular tech stack that we have mostly looked at a lot of sites kind of using a lot of these tools and libraries. And I just want to call out that you could just basically swap out the framework piece of it, which is React and Next.js with Vue or Next or Angular. And pretty much all of the content and the problems that I'm talking about today won't change. Only a small fraction of the solutions may change. So yeah, overall, it's been kind of eye-opening how this had practically nothing to do with the UI framework. And fundamentally, I would say this is a coordination problem. I know we all want to kind of have an answer or an entity to pin this on, like, oh, which tool is it? And can we go fix that tool? But it's really not simple. It's super complicated. It's a coordination problem spanning loading and bundling areas that span, you basically kind of fall through the cracks, essentially. So it's not something that can be addressed only with one platform API change or a change in one tool like Webpack. And finally, even the incentive problem is actually really complicated. It's not as simple as, oh, we have core web vitals now, so we should be good on incentives. I think the underlying problem here is the app developer actually has very limited control at best, even with the tech stack that I just showed. Plus, there are lots of other pieces to it. So I want to kind of break this up into two buckets of problems, the more obvious problems that you can easily find in tracing. And then there are sort of the less obvious problems, and you dig deeper, you find more kind of these underlying common patterns and recurring themes. So I don't want to spend too much time on the more obvious problems, so I'm going to kind of breeze through this pretty quickly. So, it's kind of all the usual suspects. For first contentful paint and largest contentful paint, we find, the things that we basically expect, things like you have web fonts or Google fonts being loaded from a different domain, not being self-hosted, lacking pre-connects, preloads. They are late discovered, and fetching of CSS, multiple CSS coming from multiple domains, lots of CSS, too many files of CSS. Render blocking scripts is a very common problem. Often this is third-party stuff. And then for LCP in particular, a very common offender is a slow hero image that's unoptimized. For first interaction delay, it sort of broadly falls into lots of JavaScript and third-party JavaScript. And this is a pretty common problem, third-party JavaScript sort of sneaking ahead and inserting itself ahead of the critical JavaScript, both on the network and the main thread. And it sometimes has a bunch of additional layout, style and layout work on the main thread. And then these large self-bundled first-party JavaScript are also can be very slow on both the network and the main thread. Another sort of obvious problem that we see with these apps is the problem of data fetching waterfalls. And the more obvious problem here is like this sort of cascade of, you first go like server render something, and then you run some JavaScript and figure out you need to go fetch some data. And then you figure out that you need, to run further JavaScript or go fetch an image to show for the LCP element. So this waterfall is like a pretty frequent common theme. I would say the subtler and less obvious problem with data is just the amount of work that's happening by doing all this fetching of raw data from REST endpoints and all of that post-processing. So that's a lot of bytes coming down the network and a lot of work happening on main thread. So again, without spending too much time on this, I just want to acknowledge that these more obvious problems are solvable. And in fact, we have successfully tackled them and shipped solutions in a popular framework-based tech stack. And I don't have time to go through each one, but it pretty much maps one-to-one from problem to solution. If slow web fonts, we can have a solution baked in for font optimization and so forth. I would say the main thing to call out here is that I would consider most of this as low-hanging fruit. These are solvable problems that can be accomplished and baked into popular tech stacks. There are a few things here, like I would say multi-flush, which is a design for flushing an early chunk. There are kind of, I mean, that's probably an exception to the low-hanging fruit category here. And this is just to sort of show that these solutions not only landed, but also actually did deliver on the performance improvements that we intended. So they did work pretty well. So that was like, my whirlwind tour of the more obvious problems. But actually, this talk is not about those features and solutions. It's about some of these deeper themes and problems with loading. And it can basically feel like an endless yak shave. Like you find the next layer of problems, and then you unearth another set and so forth. So this is a pretty apt meme. So yeah, so with that, I would say the TLDR is just a lot of different moving parts. And so this is not a 100% comprehensive list, but it's the most recurring themes. And so I want to kind of step back and take a broader look at what are these themes. And there's 3 categories. Why is basic loading still so hard? The second problem category I call as the one more feature problem, which is more JavaScript. And then the third category I would say is trimming truly unnecessary JavaScript. So starting with the first theme here, why is basic loading still so hard to get right? I would say at the heart of it, it's a scheduling problem, like scheduling of all of the resources, like developers have to optimize for metrics in the exact right order, like first FCP and then LCP, and kind of pipeline these assets have to be like by the time your FCP fires, the hero image should be ready to go for firing LCP and so forth. And so there's a lot of like scheduling, pipelining, coordination going on here. Then there's also just another very common scheduling problem, which is suboptimal utilization of network and CPU, leading to dead time. So we often see like dead time on the CPU waiting for the network, and vice versa. The other thing I just want to quickly mention is that each individual resource has to be optimized and served. But I mostly covered these kind of in the more obvious problems category, because these things can be sort of individually tackled. Like you can figure out exactly how to optimize your images and kind of have a separate standalone solution for that. The final problem here is third-party resources. And so this is actually a much harder to tackle problem just because of lack of control. And it's hard to kind of reason about when they will start fetching and how they will schedule and interleave with everything else that's going on. So fundamentally, why is this hard to get right? It requires a really good understanding of our metrics and being able to connect them with both the resources that are impacted and actual culprits. And so this is kind of hard to kind of close that loop of, oh, this was the reason, this was a culprit for CLS shifting, and then figuring that out and making solutions. It requires a fairly deep knowledge of the platform and its quirks. One common thing we keep running into is the preload bug. Like, once you start preloading, now you're sort of having to preload everything and kind of sequence all of your assets in a very specific order. And even for experts who basically figured out this, there are still limited knobs available for controlling order and priority. We don't really have much beyond basically preload. And again, even if better prioritization primitives were made available, there are still underlying problems, such as with H2 prioritization and in servers and CDNs. And secondly, third-party resources, which basically I would say add a whole, like an order of magnitude complexity to the existing coordination problem. Like even without third party, there are still too many different types of assets to coordinate and juggle and sequence. But then third party just makes it an order of magnitude worse. So in terms of what can we do, again, this talk is not about solutions, but just to kind of set the theme for this deck, I would say starting with just even knowing who all need to be coordinating on which problems would be a good first step. And I think this is why I'm actually want to engage with this audience in particular. I think there's a lot that your web platform teams could be participating in some of these problems. And then there's just a lot of kind of rallying and crossing the typical kind of org chart and company boundaries around okay, do we need to engage with servers and CDNs for some of their H2 problems that are still unsolved? Do we need to engage with third parties outside of our companies and so forth? So moving on to the next problem category, which I call this the one more feature problem. And I would say it kind of comes down to that features and performance are pretty inversely correlated. And I think we sometimes have this notion that loading is this one-time exchange of, between server to client. But actually that's not really true. And often, in a user browsing a website will have a lot of incremental stuff that they surface, additional JavaScript that needs to get sent down, additional data and CSS and so forth. And having these limits to that, we're still kind of stuck at route level code splitting as an ecosystem. And this is not really sufficing for the business needs of a lot of the production sites we see. And the second thing to point out here is budgets. I think it's a bit of a myth that, just put a budget on it. If you can just cap JavaScript to 150 kilobytes, well, you're good. But that doesn't really work, again, because it's contrary to the business goals of that website. So fundamentally, this comes down to that we don't have a good story yet for incremental delivery of resources. And I guess one issue here is that the framework DX is sort of lacking these natural seams for code splitting. And we may think that, we have dynamic imports and lazy chunks, and well, isn't that enough? And in reality, it just isn't. It is very limited in kind of the impact and efficacy. It's a 100% manual effort. It's really hard to reason about which pieces to wrap in dynamic import. And the workflow is backwards. You have to profile and audit your app and have a developer sit there thinking, is this an optional step? And is this a big enough opportunity? And then wrap it in import. And so we really need to make the right thing obvious and easy. And even if that was not a problem, I would say there's a next order of problems here with like bundler and delivery support being lacking. It's really hard to reason about and coalesce a batch of lazy chunks, and it's easy to get into this problem of proliferation of a large number of individual fetches, which can actually make performance worse. And finally, this sort of makes, with incremental serving of JavaScript, now the sequencing problem that I was alluding to before is actually harder, because now user interaction and how the features that the developer is engaging with on a site plays a role in the relative importance and order of what should be fetched first. So now we have a whole new layer of dynamically boosting and dropping priorities. And I just want to point out two more quick things here. One is this inherent resource granularity dilemma. We are pretty much with H2 still stuck with basically 10 to 20 concurrent resources. Every extra resource fetch incurs a perf penalty, something on the order of 5+ milliseconds per resource. And fundamentally, it's a trade-off between deduplication and caching being at odds with browser performance and compression. And I would say that and this is actually one of the reasons why we are still kind of struggling even more with finer grain code splitting beyond route level, because it makes this problem worse. Because the finer grain it is, now you have so many more resources to contend with. And the last point I want to make here is around critical path module initialization and be it compilation. Like this ends up becoming, when you do route level code splitting, this ends up becoming this big blocking chunk of work on the main thread, because you have done a little chunking and splitting, and all these chunks will arrive out of order. We'll do the bundler will do some bookkeeping. You have to kind of register these chunks and make sure all the dependencies are there. But then ultimately, when all of this is there, you do this sort of blocking initialization of your full dependency graph. And this becomes a bottleneck. And it's possible that finer grain code splitting actually makes this problem less, like alleviates it, just because we don't have to initialize like that whole graph, and the graph itself is smaller. But more ideally, we want to get this work out of the main thread critical path, either doing it eagerly or doing it lazily. OK. So with that, I'm going to move on to my third problem area of trimming truly unnecessary JavaScript. And I guess what I mean, the distinction between this and the last one is that the last one was about actual features, JavaScript that is needed for business needs. And then there is JavaScript that we could hopefully avoid shipping altogether. So this is one problem, this shipping. Like for modern browsers, we still ship a lot of code, legacy code and polyfills that's not needed. And module no module is sort of the pattern here for avoiding shipping that unnecessary JavaScript. Like basically, kind of, you can avoid the bundle. Yeah. So anyway, the TLDR here is we spend a lot of time kind of grappling with this, trying to implement it and land it and ship it, and run into some really big challenges. I would say the biggest one was this problem of NPM packages not being published in modern format. And then secondly, our assumptions around this wide usage of modern code and hold up in a lot of the production apps we ran into tooling problems with Babel over transpilation. So I know a bunch of frameworks have had success with this, but in our case, what actually worked was the opposite of modern, which is shipping a polyfill chunk essentially, and it helped that Webpack is dropping node polyfills. And then the last problem area I want to highlight is just bloat from suboptimal tree shaking, and dead code elimination. We have, again, coordination problem between tools like Webpack and Cursor. Libraries and NPM packages are not published in ES module format. And I think this is the big challenge, both for the last slide and for this section as well. This makes it hard for bundlers to tree shake and optimize. All right, so with that, I'll it's basically my last slide, and I just wanted to do a recap of, well, why am I talking about this? So there's a few reasons. One is just sort of awareness that there is a group that's basically my team working in this area in the developer ecosystem with the tools that developers use every day. So I think just want to get that on the radar of all of you folks. And obviously, sharing the learnings and challenges that we have found so far with this group, to hopefully towards sparking a bunch of follow-up discussions, right? This is just the start of this journey here, and definitely interested in collaboration with teams who are interested in any of the topics I mentioned. I know that was a lot of content. I have links to my deck, and I also have a backing doc with a lot more detail on each of the problem areas I covered. So I imagine there might be one or two things that might spark the curiosity of, a Blink engineer or a browser person. So please don't hesitate to reach out. And with that, I will stop. And I think we have a couple minutes, basically. So maybe time for one or two questions, if there are any. Okay, thank you, Sarah. We have 3 minutes left. So I want to open the floor up if you have any questions, or feel free to ping me either in this chat or directly on chat or Twitter. Okay. I will call it here then. Thanks, everybody.